Good morning everybody, and once again welcome back to the channel. In this particular video I would love to share some insights on loading 6.7 terabytes of data, 14 billion rows into Amazon S3 table buckets using insert override, of course Spark. So in this video I would love to share some insights with you. So I have written a wonderful Medium blog. You can of course go and read more about that. So let's break this down, right? So recently I was working on a data set, and I had to load about 6.7 terabytes, almost 7 terabytes of data I had to load into S3 table buckets. So this data was inside it was partitioned on S3 by dates, right? So I had a way to access that, right? So now instead of accessing all the data at once, I decided to basically load this month by month. But while doing so, I thought let's do an experiment and see how it goes, right? So the first time when I used the insert overwrite method, if you can see over here, fairly straightforward, right? I read the data and then I wrote into the iceberg table using overwrite partition method, right? For about, if I have the Spark UI here, yeah, you can see 3.1 terabytes roughly. I guess this is 6 billion rows roughly, right? This took about the entire job. I think it took about 1.3 hours, as you can see on the duration section over here. So that's quite a long time, right? So now the interesting thing that I observed here is when you go to Spark UI and you will see the insert override operation right before overwriting into the table, there's an exchange block. Exchange block basically means there's sorting and shuffling happening. And that was about 10 terabytes. So that's why this was taking a long time. I identified that, and in the next data dump, for example, for the next month when I was loading the data, I said, you know what, let me try because I had tried this in the past. I said, let me try setting this particular configuration. Spark.sql.iceberg.distribution mode set to none. So when I did that, it was, first of all, this is more than the first month, that is 3.9 terabyte. In the first month it was 3.1 terabyte. So that's that, and roughly about 5 billion rows. The entire job was completed in about 11 minutes. So 1.3 hours and 11 minutes. You see the huge difference. And again, this is because that that shuffling and exchange block is avoided, right? When you set that to none. Now, if you read a little bit more, I think if you want to go over this, I have the EMR settings, etc. But here, so the spark.sql.iceberg.distribution mode, when it sets to none, setting eliminates automatic shuffle and sort that Spark typically performs. Here is why it works so far. Here is why it worked for my use case. So no automatic shuffling. Spark does not perform expensive shuffle operation. No automatic sorting. Eliminates the overhead of sorting operation, because again, this is one-time huge dump, right? And it's massive data set, 3.9 terabytes, right? So disabling that really helped. And of course, then after that, I was able to run a simple compaction on that particular month, and I was able to get it done. So that's all I have to share in this particular video. So the key takeaway for you guys in this video: if you're loading massive data, setting this one configuration can speed up your batch jobs dramatically by a factor, right? So 1.3 hours and 11 minutes, you can see the total difference, right? So that's basically what I wanted to share. I hope you enjoyed the video. If you have any questions, of course, let them put them in the comment window, and of course, do your own testing, do your own research, read more about it if needed. With that being said, keep smiling, keep programming, and I will see you in the next video.